Scientific Notation, Lesson 1.6. Standard is 8EE4. The objective for today is to use scientific notation to write large and small numbers. The essential question is, why is it helpful to write numbers in different ways? Scientific notation. A really large or really small number is written as a product of a power of 10. Positive exponents. It means the number is greater than or equal to 1. 425 million in scientific notation is written as 4.25 times 10 to the 8th power. It's a single digit followed by a decimal and then the numbers that come after it. The exponent means wherever the decimal is, in this case it's between the 4 and the 2, and how many times I have to move it to get to the end. So it's 1, 2, 3, 4, 5, 6, 7, 8. Negative exponents. It means the number is less than 1. This really small number in scientific notation is written as 2.64 times 10 to the negative 7. My first digit between 1 through 9 is 2. I have to move the decimal from here. 1, 2, 3, 4, 5, 6, 7. Thus, an exponent of negative 7. So when I have to move to the left, my exponent will be negative. Example 1. Write the number in standard form. Standard form is just the way we normally are used to seeing numbers. So since I have a positive exponent, I'm going to be moving in the positive direction to the right. So I'm going to start where my decimal is. And the exponent tells me I'm going to be moving 5 times to the right. So I'm going to jump 1, 2, 3, 4, 5. And wherever I don't have any digits, I'm going to be placing some zeros. So I have 1, 2, 3. So now I'm going to go ahead and rewrite my number. And I'm going to place my comma. So my answer is 742,000. Example 2. Write the number in standard form. Since I have a negative exponent, that means I'm going to be moving 2 times to the left. So again, I'm going to start where my decimal is, and I'm going to move 2 places to the left. 1, 2. So I'm going to go ahead and fill in my placeholders, which are my zeros, and my empty spots. And I'm going to move my decimal here, and then add the 0 in the front. So my answer in standard form is 61 thousandths. Example 3. Write the number in standard form. Since my exponent is positive, I'm going to be moving to the right 2 times. Again, I'm going to start where my decimal is, and I'm going to be moving 2 places to the right. 1, 2. So my new answer is going to be 371 and 4/10. Example 4. Write the number in scientific notation. I know that when I don't see a decimal, there's always an invisible decimal at the very end. In scientific notation, it's always 1 digit and then the decimal. So my decimal would be right here. So I need to see how many jumps it's going to take for me to get to the left. So it's going to be 1, 2, 3, 4, 5, 6, 7. So that means it's going to be 10 to the power of 7. I know my exponent is going to be positive because this number is greater than 1. Now I'm just going to add my numbers in the front, which is 1.414 and my multiplication sign. So now this is written in scientific notation. Example 5. Write the number in scientific notation. I can see that this number is less than 1. Since it's less than 1, my exponent is going to be negative. Now, in scientific notation, my decimal is always going to be after the first non-zero digit. So it's going to go after the 8. So my answer is going to be 8.76 times 10 to a negative power. Now we're going to have to see how many jumps we have to make. 1, 2, 3. So my exponent is going to be negative 3. So in scientific notation, my answer is 8.76 times 10 to the negative 3. Example 6. Write the number in scientific notation. I know that this number is less than 1, so my exponent will be negative. And I know that in scientific notation, I'm going to place my decimal after the first non-zero digit. So it'll be right here. So I'm going to write 1.14 times 10 to the negative something. So I'm going to go ahead and see how many jumps I have to make. It's going to be 1. So my answer in scientific notation will be 1.14 times 10 to the negative 1. Example 7. Change the number from decimal notation to scientific notation. I know that since this number is greater than 1, my exponent will be positive. And I also know that in scientific notation, my decimal is going to go after the first non-zero digit. So it will go right here. So I'm going to go ahead and write down 3.45 times 10. Now I need to see how many jumps I'm going to make. 1. So it'll be a positive 1. So my answer in scientific notation is 3.45 times 10 to the positive 1. Example 8. Change the number from decimal notation to scientific notation. Don't let this one confuse you. It is not written in scientific notation. Remember, in scientific notation, the decimal needs to be right after the first non-zero digit. So what I need to do is go ahead and expand this. So I have 62.3, and my exponent is a 4, so I need to move my decimal 4 times to the right. 1, 2, 3, 4. Now I'm going to go ahead and move my decimal because I want it to be here after the first non-zero digit. So I'm going to start at the end and move 1, 2, 3, 4, 5. So that means my answer is 6.23 times 10 to the power of 5. Example 9. Change the number from decimal notation to scientific notation. Again, I notice that this is not written in scientific notation because my decimal should be after the first non-zero digit. So I'm going to go ahead and expand this, and I know that since I have a negative exponent, I'm going to be moving 5 times to the left. So I'm going to rewrite my number, 45.6, and I'm going to start where my decimal is, and I'm going to move 5 places to the left. 1, 2, 3, 4, 5. Now I want to get my decimal right in between the 4 and the 5 because that's the first non-zero digit. I'm going to start at the end, and I'm going to move 1, 2, 3, 4 times. So my answer is going to be 4.56 times 10 to the negative 4.